Hello, wonderful people. Happy Friday. It's going to be cold today, but maybe you get to go outside this weekend. So let's get right to it. Chapter 5, or Unit 5, rather, it has a bunch of parts to it, more units than 8. I have this compiled into 2 presentations, but it's just one now. I compiled it. So let's get right to it. Let's look at these fancy words here: agriculture, pesticides, green revolution, and fishing. I'm sorry, I can't get that word in there with all these programs I'm running right now. But these are probably my 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 the best chapters, my favorite chapters out of or units rather of environmental science, especially agriculture. Okay, so let me change slides here. Oh boy. Okay. All right. So the first term I want you to understand is something called the Green Revolution. It's misleading because you may think that the Green Revolution is when all this technology for alternative fuels or alternative energy sources became a thing. But no, that isn't the Green Revolution. The Green Revolution was a huge revolution in agricultural techniques. Uh, those agricultural techniques enabled us to have tremendous amounts of food around our planet. And so, what were those agricultural breakthroughs that really produced a lot of food? Well, it was around the 1960s. Let's try to give some time context to this. 1950 to 53 or 50 to 52, that's when 50 million people died in China of starvation. So there was a point in our history where food shortages was a thing. Are they a thing right now? Well, currently, we can produce enough food to feed everybody on our entire planet. The issue is that it's not dispersed around our planet equally. So you're still going to have starving people. So then you could argue, well, should we basically ship food to other countries that are starving? Well, that is a humane thing to do, but does that fix the issue? And so let's say we start feeding another country, their population is going to go up. Did we fix the problem? Well, we're going to have to continually feed that other country. So it's complex. I think what we need to think of is building infrastructure in countries to allow them to feed themselves. So my brother told me the story. I don't know. I think I read the story, but uh, my brother, one time when we were young, I was asking him to take me to a teen club, and my mom didn't want to drive me. So my brother, I was like, "Come on, you're not going nowhere," and he ends up charging me money. And to this day, I bring that story up um, because he said, "Well, if I did it for you for free, then you would basically expect it all the time." Where am I going with this? Give a man a fish, feed him for a day. Uh, Teach a man to fish, feed him for a lifetime. What does that mean? That means if we're just giving stuff away, it doesn't necessarily fix that problem. Okay, if we build the infrastructure, enable them to feed themselves, then this is part of the demographic transition as countries come from the less developed side more to the developed side. You start actually seeing a population leveling out, if you will. So it's all connected. Anyhow, getting back to the Green Revolution. So, what were those big technologies that came out roughly around the 60s? Right. And that was going to be the introduction of GMOs. If you don't know what a GMO is, please get associated with it right now. There's so many different things out there in the world to express a GMO. So let's try to get a whole understanding of what a GMO is. First off, it's a genetically modified organism. That could typically could be a plant, it could be a crop, corn, it could be soy, it could be wheat. It could also be a type of chicken. It could be a type of salmon. It could be a type of pork or cattle. So genetically modified organisms. That means there's some modifications to the genome of that organism. Now, typically for agricultural purposes, they're going to be um, like good adaptations for the farmer. Are they good overall? Well, they're going to promote growth. We'll talk about holistically if it's good in many different aspects. So basically, in one aspect for the Green Revolution, they produced a lot more food. So that is definitely a pro. Okay. Now the introduction of pesticides. So chemical pesticides specifically. Now, are these a good thing or a bad thing? You take it with a grain of salt. Pesticides or pests are things that are going to eat your crops. Anything with an "icide" in it means something that's going to kill that. So you have a pesticide, which kills pests. You have an herbicide. Herbicides are going to kill herbs or plants. You're going to have a rodenticide that's going to kill rodents. You're going to have a fungicide, which will kill fungi or funguses, and even an algicide, which is going to kill algae. So depending on what comes before the word and "icide," that's going to dictate what it's potentially going to kill. Pesticide is a grand term to describe all of those pesticides. But specifically in crops, I believe the herbicide is what we use most commonly. All right. And we're going to use some other pesticides or insecticides to kill some insect eating bugs or um, insect crop eating bugs. And so we'll use an insecticide for that. Right. We also started using industrial fertilizers or chemical fertilizers as well. So even though previous to the 1950s we used things like manure, well, if we needed to have faster food production, we're going to basically start using some chemical fertilizers. So this was the Green Revolution. There were huge advancements in these, and they became available to farmers. And this enabled us to grow more food. Grow more food is going to lead to a population boom. And that's what we do see in the data. There was a population boom in that in the 60s. Okay, let's continue. I love trying to change slides. I don't know how to do it, guys. One day I will. One day I will get to learn how to change these slides. Yeah. So let's go more in detail about a GMO. And you might have heard on the news that these are bad things, and I'm not going to say they're bad things. I'm going to tell you both. And I'm like you look up your own and research to see if they're good or bad. Are they good? Are they bad? Well, they stand for genetically modified organisms, meaning are they natural or not? There's two ways to identify this. Some some ways of genetically modifying could be simply as artificial selection, like when we were taking particular dogs and trying to get a specific characteristic. And let's say, we took two wolves and eventually we get a Chihuahua. We could have bred them and so on and so forth. And that would be kind of genetically modifying. But typically, that's not what we're talking about when we're talking about genetically modified organisms. We're talking about literally taking the genome and splicing in another gene inside of that plant. Okay. And so when you're preparing for this debate, if you're ever preparing for a debate in regards to GMOs, try to understand what, if they try to say we've been doing it for years, well, what type of genetic modification are you talking about? Are you talking about splitting the genome? Because we haven't been doing that for decades and centuries. Have you talking about just artificially selecting? Yeah, we've been doing that for quite some time. But anyhow, I digress. Let's go to the latter when we're discussing, literally splicing maybe even two different organisms together. Okay. And, I'm not going to say you make a cat dog, not those two species, but perhaps you can take a gene of a particular pig and then splice it into the genome of a bacteria. And now you have that bacteria making that gene that was from the pig. And I believe we get insulin that way. And there's other different things that we could potentially get. And we're going to go into detail about those. Okay, so we're talking about hardcore genetic modification. All right, this right here and this cow, it looks a little like me if I was a cow. Is this a cow? Is this a male or a female? This looks like a male. It looks like a steer actually. And I believe when you research this over muscled cow, this is something that happens because of a mutation. This is something that occurred naturally. But this is not genetically modified. In corn, though, I would say about 80 to 90% of our corn in the United States is genetically modified. Okay, we're going to learn how you can determine if your crop is genetically modified or not. But I would say probably 80 to 90% of all of our products in the supermarket are going to be made from GMO corn as well. While I'm talking about corn, corn is the number one crop in America. All right. Number two is going to be soy. Okay. So corn and soy. Why those two crops? Well, corn grows really well in America. Okay. way back when the Native Americans were here. That was one of the main staples. It grows really well. Certain crops grow really well in certain areas. You get your oranges in Florida, you get pineapples, mangoes, Caribbean areas like that. But corn grows great here. Corn is really cool too because you can dry out corn, and corn stays stable for a very long time. So it has a long shelf life once it's dried out. Once it's dried out, you can feed it to cattle. Once it's dried out, you can feed it to chickens. Chickens love it. You can feed it to pigs. You can feed it to a lot of things. It has so much sugar in it. It's very sweet. So manufacturers have learned how to take out the sugar, high fructose corn syrup, and now manufacture a lot of other products like soda, like juices, like Gatorade, like a lot of things that have high fructose corn syrup. Perhaps every single thing that is sweet, or every other thing, unless it has another type of sweetener, it's going to have high fructose corn syrup. High fructose corn syrup is going to be one of the cheapest sweeteners out there because there's so much corn. You getting it? Dog foods are going to have corn in it. A lot of fillers are made with corn. Why? Because there's just so much corn. So corn is the number one crop. There's some genetically modified corn out there, and it's really, really interesting. We're going to get to know more about them. All right. Our number two crop is going to be soy, and that's why we have so many soy products coming out. We have soy milk, we have soy meat coming out now, we have tofu. These are all soy products. And if you're a manufacturer and you want to get a product, right, are you going to choose a product that's very rare? Then you're going to have to sell it at a high price. Or are you going to sell a product that you have a lot of resources so you can make it to something that you can sell? So soy and corn, you will see majority of products are going to have those two things. Let's try to change the slide here. Okay. So remember how I was saying that there's some hardcore ways of doing some genetic modification. All right. Let's talk about this. So the two players that we're having here, and this is called BT toxin. Say it in your head, BT toxin. And sometimes they call it BT corn. Okay. Now, there is some type of a bacteria that produces a toxin that would actually kill the larvae of, uh, of some corn eating crops. Okay. And what scientists have done in BT corn is taken that toxin out of that bacteria and now have spliced it into the genome of particular corn species. So think about this. You got the whole genetic sequence, GA, TTA, CA, remember adenine, guanine, cytosine, thymine. And we're going to splice the code for making this BT toxin. And then we're going to take that code and we're going to put it into the genome of corn. And now we're going to plant corn. And when corn grows, now it's automatically making that toxin as it's growing. So when that larvae tries to eat that corn, the corn is already producing its own pesticide. Boom, science. Boom, beautiful. Okay, gorgeous. And we can produce a lot of corn that way. And now the corn is producing its own pesticide. So that's one way to view it. Other way of viewing that is, whoa, the corn is now producing a pesticide. And now if I eat that, will I be affected by that pesticide? So there's been some scientific evidence that indicates that there's not going to be any negative side effects. Despite that, there's some proponents that think, you know what, it's pesticide. It has to hurt them. If they hurt them, it's going to hurt us up the chain of command. So I'm going to allow you guys to research and make your own decision. Is that something cool? Is that something not cool? To put genes from different organisms into one to make it a stronger individual. For food production purposes, I think there's no debate. For health purposes, I think they could have some debate in regards to that. But this class is not about that. This class is to show you how cool GMOs are and how they enable us to increase our populations and have a stable food supply. Because without a stable food supply, basically we're going to go to war, and you don't want to go to war. That's not cool. So how cool is this corn? So now we can produce more corn. And since we can produce more corn, we can feed more people. And so when people are fed, typically they're not fighting for these resources of food. That means less war. Okay, so this is a very famous GMO, BT toxin. So please remember this as a stable example if you were trying to debate that. So BT corn. Okay, there are other examples of types of crops that are other cool things that are made into crops. And For instance, let's say you lived in a country that can grow rice, but rice is typically starchy. It has a lot of carbs that give you energy, but it doesn't have a lot of vitamin A. And let's say a large portion of your population is going blind. They don't have any vitamin A. So there's something called golden rice has been genetically modified to include vitamin A in its structure. That's pretty cool. That's like eating a carrot and rice at the same time. So that is one of the cool things of that. Um, you know, is there a con to that? What if you're allergic to carrots? So sometimes people think that there could be some allergies if you don't know what you're necessarily consuming if it's not in its purest form. However, other proponents are saying, this is preventing blindness. Get out of here with that nonsense, man. I don't want to be blind. We need vitamin A, and it's a vital nutrient because without it, we'd be malnourished, and malnourished can cause disease like blindness if you don't have vitamin A. Make sure you know that. Um, so golden rice is another. So now we're adding ideas to our head of the understanding of a GMO. We have a simple idea, then we have more complex with BT toxin, and now we're going to even vitamin A or golden rice. All right, let's continue here. I'm so sorry. I need an editor to edit all my good stuff here so I can know which slide I'm in. I have this laser on. I don't know how to turn it off. Let me turn the laser off. The laser's not going anywhere, and it looks like there's a delay. Okay, so GMOs are also identical twins of each other. Try to hold on to this idea. So there's this huge company. I'm not going to throw it in. Well, you know what? You're going to hear about it in popular movies. You're going to hear about Monsanto, M-O-N Santo, S-A-N-T-O. And it's the largest manufacturer of GMO seeds. Now, money is a big thing here. Okay. Now, if you were a company that invested a lot of technology and a lot of money and a lot of funds in creating seeds, okay, you're going to want to get a return in that. So if you want to get a return in that, um, you're going to have to sell your seeds. But if you sold a seed and then it grows into a plant and then drops its own seeds, that means that a farmer is only going to basically buy your seed one time. Well, Monsanto ingeniously um, has made a seed that is not fertile the following year. So it's like called a kill sequence. So all their seeds are not necessarily fertile. So this ensures that Monsanto is always going to be selling seeds to the farmer. Previously to this, farmers used their seeds from their previous crops. So this is an extra cost for farmers. So you have two enemies here: farmers and Monsanto. Okay, because both of them are going to have to lose funds in some type of way here, or there's going to be a redistribution of powers in how the businesses perform. Anyhow, going on with this term I'm trying to get to. Now, since they're identical seeds, they're all what we call a monoculture. Mono meaning one type of seed, and they all are identical twins, and they're all, let's just say, corn. So a lot of farmers now are monoculturalists, if you will. They plant one type of crop all over their acres. And so here behind me is a picture of some corn. Now, monocultures are easier to I guess, treat because you don't need different types of pesticides. You basically use the same one. You just need the same type of vehicle to run this thing. And so they're a little bit easier, which brings down the cost. So this is part of that green revolution. All right, I'm going to pause it real quick. So, excuse me, I just had to take a quick break. So monocultures are also going to decrease biodiversity. Okay. So because they're exact twins, then automatically you're shrinking biodiversity. You're shrinking the genetic diversity within a population. So they're all twins. Now that's a good and a bad thing. It could be a good thing. Actually, it's always a bad thing. Never a good thing. So imagine one of them gets sick. If one of them gets sick, all the rest of them are going to get sick as well. Of course, these are like super breeds of corn, But if one gets sick, then they all get sick. Now, another thing that happens is that since you have nothing but like an ocean of corn, if a pest species becomes resistant to any of the pesticides that are there, or let's say resistant to the BT corns and able to eat that, then you're going to have a super pest because it's just going to have so much of that one corn. So, like, a particular pest are specific. They may just eat one type of thing. It's not like, like humans, we eat so many different things. Particular type of insect or particular type of fungi or particular type of rodent may just eat this one type of thing, and if they just see all of their food, they start to proliferate and grow like crazy. And so those are some cons of having some monoculture. All right, definitely understand some cons associated with monoculture. All right. Now, how can you tell if your crops are GMO free or without pesticides? Well, you could look for some labeling. Okay. And the Non GMO Project is a company that's going to certify a product that says it does not contain GMOs. Right. USDA is the strongest label. That means this doesn't have any pesticides, artificial fertilizers, any type of genetically modified organisms. So this is different from this in that non-GMO just means no genetically modified seed. It could have some pesticides. USDA organics can mean that it doesn't have any pesticides, it doesn't have any hormones, it doesn't have any artificial fertilizers. It's basically organic in that form. All right. Other labels you may see is something called cage free. And cage free is going to mean that the particular organism, and usually cage free involves chickens. That means that the chickens are going to be free range, that they're out. Okay. Pasture raised is different. Pasture raised means they're actually out into the grass, but free range could mean that they're just out of their cages. They could be in a big enclosure, but they're just running around inside. Pasture raised means that they're actually eating grass, they're exposed to sunlight, and so on and so forth. Organic, it could be caged organic. So if you add organic pasture raised, that means that they're not being fed any type of feed that has chemicals in it, fertilizers or hormones. If it just says pasture raised, it could mean that they're going to have some artificial feeds fed to them that contains certain pesticides, some things like that. So if you wanted, let's just say, I guess, you know, it's typically involved with price. Organic free range eggs are going to cost the most. And so that means your chicken is out in the sun and it's not, if it is fed other than grass, it's going to be fed in organic feed. And that means that has no GMOs at all. Okay. So know your labeling. All right. So grass fed is something different. That typically involves cattle. And grass fed is going to mean that a lot of people don't know this, but cows don't necessarily eat grass their whole entire life. So it's a growth process. Grass fed is a slower growing cow before you can harvest that cow, and so grass fed organisms tend to cost more. Now with grass fed, people argue that grass fed cows are leaner, so therefore there's not as much fat in the meat, and so therefore the meat is healthier. Some people say that that's more a natural diet, so they produce less methane because they have evolved to eat grass as opposed to eating grain or corn. But typically corn is cheap, so grass fed, there's the big difference. You're going to either have something that's growing slowly eating grass, or you're going to have something that's going to grow fast fat with the corn. I've experimented. I eat some grass-fed beef, and I also eat corn-fed beef. And it could be something like I have to get used to the grass-fed. I know it's good for me, but just like a vegetable, sometimes I'd rather have the fatty one. That's my personal preference. You should probably have your own personal preference. I do like the corn-fed when I'm eating something like a filet mignon, and I want a fatty meat. But I definitely could do a stir-fry steak and try to get that grass-fed beef there in that aspect. Okay, so there's a little intro to labeling. If you have any other questions, you guys can let me know. All right, let's do one more slide and we'll call it a day. Okay, so I don't know where this slide came in, but I'm pretty sure it has a reason. And maybe it was a free response that we were going to go over or eventually go over. And we're going to just say, oh, you know what? I thought we were going to go to a zoo, and that's why I basically wanted to defend this. So we won't talk about this because the zoo is going to be a tough situation for us right now. So we'll just go to the next slide here. All right. So GMOs around the world. All right. It particularly per country. All right. This could tell you, all right, 10 Latin American countries grow GMOs. All right. 39% of crop areas devoted to GMOs globally is in the US. So we do a lot of GMOs. 39% globally is just in the US. All right. So India is the number one cotton producer in the world. 96% of India's cotton is genetically modified. So India produces a lot of cotton. It's a fun fact. Okay. And look at the crops that grow in particular areas. In the Americas, we have corn. Corn can grow all the way up into south, all the way up into the north. Okay. Corn is going to grow up in European areas here. Okay. And so here's a fun fact. You can pause the camera and really get to look at this image right here. All right. I hope you enjoyed our lecture today, and I'll see you later.